In our third example, using substitution method, we have x plus y equals 3 and y equals 4 minus x. And just for a moment, I want to talk to you about substitution with a different problem. What if we had x plus y equals 5 and we knew that y equaled 3? I could say that x plus instead of y, I could say 3 because 3 is the same thing as y. And then I could solve for x and get that x is 2. Okay, so that's just a side note. I'm going to do the same exact thing here. And since I have y equals, since I have a variable by itself on one side, completely by itself, y equals, I can put that into the other equation, x plus y equals 3. But instead of putting y right here in these parentheses, I'm going to put 4 minus x. So I get x plus 4 minus x equals 3. So now I can solve for x, and I start off by doing that. By combining like terms, and I see an x and an x. So 1 minus 1 is 0. So the x's cancel in this case, and I get 4 equals 3. That is not a true statement, so no solution. So we know how to solve using substitution, but there's another way, elimination method. So let's read through this real quick and then we'll work some examples. Now, in this method, we eliminate a variable by adding the two equations together. But first, you had to make sure that the two equations are in the form ax plus by equals c and stack the two on top of each other so that our x's are on top of each other like this and that our y's are on top of each other. And then on the end, you're going to have these two numbers on top of each other. Then you determine if you were to add down, add those x terms and y terms and constants together, could a variable be eliminated or canceled out? So for this to happen, the coefficients of the same variable must be opposites or additive inverses. So like, if I want x to cancel out, I need them to be the same number but different signs, just like 2x and negative 2x, because if I add them together, they would go to 0 and they would cancel out and be eliminated. If the variable can be eliminated, we need to add down, but if it can't, we need to determine a way or an equivalent form for both equations that will result in eliminating a variable when we add down. So we multiply one or both equations by a number in order to have two equations so that the coefficients of one of the variables have the same number but opposite signs. And then we can add down, eliminate a variable, and solve for the remaining variable. Once we solve for that remaining variable, we can substitute it in to the equation and solve for the other unknown variable that we canceled out. And I'm going to start off by adding them together to see if one of the variables eliminate. And so 2x and 2x and x is 3x. And then y and negative y go away. And then 2 and 7 give me 9. So these y's canceled out. And so now I can divide by 3 and solve for x. X equals 3. And once I've solved for x, I can plug it into the original. Well, one of the originals. So like 2 times 3 plus y equals 2. And now I can solve for y. So 6 plus y equals 2. And I subtract 6 from both sides to get that y equals negative 4. And our very final answer would have to be in an ordered pair, and it would be 3, negative 4. In this example, I start off by making sure that they're both in standard form, and they are. My x's are on top of each other, my y's are on top of each other, my constants are on top of each other. And I add it together to see if anything cancels, any variables cancel, and they do not. So I'm going to have to rethink it. I'm going to have to decide first what variable I want to cancel, and then I'm going to have to manipulate one or both of these equations by multiplying so that I get an equivalent form of the equation and can add them together so that a variable cancels. So I'm just going to, it doesn't matter what I choose, but I'm going to choose x. So if I'm going to choose x, I need the same number. I need them to be the same number and different signs. So the bottom equation is 5. That means I'm going to multiply the top by 5. And the top equation has an x value of 4x. So I'm going to multiply the bottom one by 4. And since the 4x and the negative 5x already have different signs, I can just leave this 5 and 4 that I'm multiplying by, I can leave them as positive numbers. So I have to multiply that 5 by the entire equation. So 20x plus 15y equals 55. And now negative 20x plus 8y equals 4 times 15 is 60, I believe. Okay, and now I can add the two together. So now do you see that once I add these two equations together, the x's cancel just like I had planned. And now I add everything else together. I get 23y equals 115. And I need to divide both sides by 23. And I get that y equals 5, but we're not done. I don't know what x equals, but I need to plug x into one of the original equations. Excuse me, it can plug y into one of the original equations and solve for x. So 4x plus 3 times y, but I can put 5 because I know y is equal to 5, equals 11. So 4x plus 15 equals 11. I can subtract 15 from both sides and get negative 4 equals, and that 4 looks bad, negative 4 equals 4x. You just divide both sides by 4 at this point. X equals negative 1, so our coordinate is negative 1.